Hi everyone, we're going to take our class notes on 8-7 complex numbers, which means we're going to see imaginary values. Today is April 22nd. We should know that if we see a square root of -1 underneath the root, it represents I, and I is more simplified than the root, so we definitely want to make sure we have I in our final answer and not root -1. If we know that I is root -1, we can find out what I squared is by squaring both sides, which is what we just did yesterday with that power rule. And so if I square both sides, I get the I squared on the left and I get -1 on the right. So I squared is equal to -1, which is important to know. So anytime you have an I squared in your problem, you want to sub in a -1. And we've done some of this already in chapter 12. And so if we have root -b, so not a 1, just any number underneath the root with a negative, we should first remove the negative from underneath the root. Think of that as maybe being perfect and it coming out as something different, and it comes out as our imaginary piece. All right, so into examples we go. So from earlier and from the quiz, I know we've mastered simplifying just single roots, and we're dealing with square roots here, so no higher index for these. I'm going to break it up. The biggest perfect square that goes into 44 is 4, so I'm going to write this as -4 times 11. The negative comes out as I, and the 4 comes out as 2, so I get 2I root 11 is not perfect, it's staying in. So remember, the negative is perfect and the 4 is perfect, and they come out as something different. And we're done with the first example. You can't multiply both of these together to say positive. You have to first say I root 8 times I root 6. Now you can multiply the 8 and the 6 together and the I together. So I'm getting I squared equals, I times I is I squared. Root 8 times root 6 is root 48. And 16 is the biggest perfect that goes into 48. Yes. So I'm going to keep my I squared. Although I'm going to replace I squared, I know I squared is -1. And then I'm going to write 16 times 3. 16 is perfect. It comes out. 3 is not. It stays in. When 16 comes out, I multiply it with that -1. Done with the second example. I'm going to first remove the perfect negative, which is I root 40 over root 10. If they're both under the root, I can simplify them. So this is easy as 10 goes into 40 4 times. So I get I root 4. Now 4 is perfect. 4 comes out as 2. So I'm going to write it as 2I. You could write it as I times 2, but really you want the real number part first and then the imaginary part. So 2I ends up being our answer for our third example. Fourth, let me go to the next slide over here. Complex numbers. So now you're seeing a complex number in the form a plus bi. That's a complex number. You have a real part and an imaginary part. So that is what we call a complex number. We have a real and an imaginary part, or even just imaginary, because a could be 0 and we still have a complex number. And you're just asked to perform the operation. So you're still simplifying. You're adding, you're subtracting, you're multiplying, you're dividing, whatever you're given. So in our first example, we're asked to subtract. So the 8 minus 5i will come down, and I subtract the 12, and I subtract the -3i, which would become +3i. I want it with the real parts first, so that's going to be a -4. Then my imaginary parts, which are going to be a -2i. You do not have to factor out the fact that those have a 2 in common. You can just leave it that way. That's a complex number, real part, imaginary. I can tell in this one I'm being asked to multiply, so I'm going to multiply these together. I can't use the pattern because I see some in difference, but not the same first term. So I have to distribute. 6 times 2, 12. 6 times 4i is 24i. And -4i times 2 is a -8i. And a -4i times 4i is a -16i squared. So what do we have to do? Well, we should sub in for I squared. Anytime we see an I squared, we should sub in a -1. -16 times a -1 is a +16. These pieces we can put together to get a +16i, and then the +12 could come down. 12 and 16 are like, we should put those together to get 28. That's the real part. And there's our complex part, the imaginary part. Final answer will stay 28 plus 16i. Dividing, we have to use what we just did earlier in this chapter, which is conjugates. So to get an imaginary piece, you have to divide these, and can't have imaginary pieces, just like you can't have roots in the bottom, you can't have imaginary. So I'm going to use the conjugate, 4 plus 3i and 4 plus 3i. So just distributing in the top and using the pattern in the bottom. I'm going to do the bottom first so we can focus on that pattern. Square the first, square the last, and put subtraction in between. So this is going to actually become, hopefully you're saying, positive 9. In the top, let's see what we get. 24 plus 18i plus 8i plus 6i squared. So this will become negative 6. I'm just going to circle it. Excuse me. Negative 6. And this whole part's going to become plus 9. So in my next step, I can say, well, 24 minus 6 is 18. And 18 plus 8 is 26. And keep the imaginary part there. And then 16 plus 9 is 25. Now, if all three of these numbers had something in common, we would simplify just like we learned in the previous sections before the quiz. Okay, the last and final part of our notes for today are going to be finding each power of I. So we know, and these will be given on the test on Monday. These I'll give you, and then you need to find bigger I being raised to a different power. But what we know and how we can find the rest of these is we'll actually start to see a pattern. But we know that I is I, that when we see I, we want to use I and not the square root of negative 1. We know that I squared is negative 1. So I could break up I cubed and say, well, I squared times I to the first is I cubed, which means I squared is negative 1 times I. So negative 1 times I is a negative I. And then I to the fourth, I could break it up in different ways, but using what I know already, I could do this and this, but I'm going to go with the I squared. I'm going to say I squared, and I'm going to actually use parentheses here. I could do I squared and I squared, but I can also do this because multiplying these gives me 4. I squared is negative 1. A negative 1 squared is a positive 1. I'm going to put I to the first is I to the second is negative 1. I to the third is negative I to the fourth is 1. Maybe some of you are already catching on to the pattern. If not, you might break this up into I to the fourth times I, using what we just found for I to the fourth. 1 times I is I. And so I recognize the pattern. Odd degrees starts I, the next odd degree, negative I. The next odd degree, I. So the next odd degree is going to be negative I. With the evens, I squared, first even squared, 2 is negative 1. Next even is 1. So I to the sixth, the next even, the pattern's going to say negative 1. The next even, I to the eighth, is going to say, pattern's going to say 1. So even degree, negative 1, 1, negative 1, 1 for the pattern. Odd degree, I, negative I, negative I, negative I, and you can keep going that way. But I really want you just to be able to use these to help you simplify things that look like this. So I'm going to write I to the eighth using that, and 8 times 4 is 32, so that's too much. 8 times 3 is 24, and I need to get to 28i. So I have 24 here, and then I need 4 more to get to 28i. So you can break this up in several different ways, guys, so don't think that this is the only way. I've had students do I to the 8th times I to the 8th times I to the 8th times I to the 4th, and that works just as fine, just as well. So I to the 8th, we said was 1. 1 cubed is 1. And we said I to the 4th is 1. So I have 1 cubed times 1. which means my answer is going to be 1. Negative exponent, right away I need to write this as 1 over I to the 9th. And then, again, you know that I'm going to write I to the 8th times I. And so I have 1 over I, because I to the 8th is 1. 1 over 1I if you want. But again, we have to keep going because we can't have I in the bottom. So I'm going to multiply top and bottom by I. You can do positive I or negative I. Really, the conjugate would be negative I. So let's use negative I. Either one, though, you'll still get to the right answer. So I get negative I over negative I squared. What do we sub in for I squared? A negative 1. A negative 1 times a negative 1 is 1. So we end up with negative I. Negative I is our final answer. And that is everything for today. A lot. So take it all in and feel free to private comment if you have questions. Give the homework a try and have a great day, everyone. Bye.